Hello, my name's Bob Willis and welcome to Defect of the Week, brought to you by the Robotic Soldering Experience. But more about the experience a little bit later on. The first defect we would like to deal with is solder balling. Now, solder balling is not uncommon in other soldering processes, but when we look at robotic soldering, we start to see perhaps an increase in solder balls being visible on assemblies after soldering. Now, solder balls have been seen in hand soldering over the years, and there was an increase in solder balling during the introduction of lead-free technology, where myself and other production staff were being introduced to perhaps slightly different techniques that might be used for hand soldering in manufacture. But when we talk about robotic soldering, either with contact or laser, we're starting to talk about something slightly different. It's fair to say that most of the material manufacturers have worked hard to redevelop some of their cord wires to minimize the possibility of solder balls being produced during a soldering operation. However, using laser or using contact soldering, perhaps we are not looking at the technique to get the process right to minimize the possibility of solder balls. So yes, we can look at materials, we can certainly look at the techniques we're using when programming systems, be it speed, temperature, throughput, and obviously something that really you shouldn't be doing in a normal hand soldering operation, which is adding solder directly to the tip rather than to the joint area, which sometimes is quite often common in robotic soldering. So another thing we could look at is the volatility of the material, i.e. the flux and the flux solvent system within the cord wire. And one of the things that we have seen has quite a marked improvement on solder balling is the way in which you set up the feeder system. Now, feeder systems feed the wire to the point of soldering, as we all know. But feeder systems in the industry have evolved over the years, and the indentation of the wire and the indentation depth during the feeding mechanism by the feeding wheel can have an improvement on the number of solder balls produced. As we see in this video recording, you can see me doing experiments with wire which has not been indented, and you can see solder balls produced. Now, if you look at a video clip where I've indented the wire, so the flux is actually, or the energy from the flux is escaping prior to the solder becoming a liquid. So the volatility is reduced, and the energy to drive solder away from the tip onto other exposed areas of the board is reduced. So look at the wire, but also look at indentation and how the flux escapes from the wire even when it's not in a liquid state, as shown in this video clip. So thank you for listening to Defect of the Week, brought to you by the Robotic Soldering Experience. So what is the Robotic Soldering Experience? Well, it's a process, a group of processes, material manufacturers and suppliers brought together to demonstrate their equipment. Now, I've been running experiences with a number of different topics over the years, but this is the first on robotic soldering. So if you'd like to participate or find out more information on what we're doing in terms of the practical demonstrations of robotic soldering and also the online training opportunities there are, then please contact us for further information.